Alright, welcome to the function station. The first thing we're going to do is just write down a couple things to remember. So when we're dealing with functions, you want to remember what a function actually is. So for a function, you have one input for every output, okay? So this means your x's don't repeat. You also want to remember domain is your x values and range are your y values. Okay? There's a couple instances where you're going to have to convert like percents to decimals. So whenever you're converting a percent to a decimal, all you're really doing is moving your decimal place, right? So if I have 65%, to convert that to a decimal, I'm just going to take that 65%, right? My decimal place is starting here. I'm going to move it to the left 2 spaces. Now if I were going the other way and I wanted to convert a decimal into a percentage, and let's say I started with 0.13 and I want to turn it into a percentage, I'm just going to take that 0.13 and move my decimal place 2 places to the right. You also want to remember that a function is just the same thing as an equation, okay? So in a function, you just have f of x, and that's the same thing as y. So if you see this, it's the same thing as having a y. And then if you need to solve for something, so f of 2, that just means you're plugging 2 in for all the x's you see, right? So whatever number's inside of those parentheses is what you're actually going to be plugging into your problem. So you can have linear functions, quadratic functions, exponential functions. It's just another way of explaining the type of equation you have. What else should you know? Ways to test for a function are to remember this one input for every output, but also you have your vertical line test. So that means that at any point on your graph, it should only pass through the vertical line one time, right? So if it passes through more than once, then it's not a function. And you also have like recursive functions. So recursive functions is just talking about if you have like now, next, right? So we're going to do a couple guided practices or some guided examples that'll hopefully jog your memory, like what that looks like or should look like and what you should do when you see that. And then also with now and next. So for now and next, you're going from y to y. So you're just looking at your y column. You also have, though, input, output, and that's going from x to y. Okay? Alright, so let's go and let's do some guided practice. So I'm going to look. Okay. So the first question says, during a sale, you guys can like pause if you need to write that stuff down and then come back to this. But the first one says, during a sale, the store advertised that every item in the store was 35% off the marked price. During the sale, what was the cost in dollars of an item that was marked X dollars? So I see the word percent here. So I need to pay attention to that. So 35%. I need to know that as a decimal, that's going to take this 35 and move it, and move it to the left twice, right? So now as a decimal, that's going to be 0.35. And now, when I'm thinking about how sales work at a store, I know I need to multiply the total cost of my item, whatever I'm buying, by this to see how much is going to be taken off, right? So this needs to be paired with the total. So it's this 0.35 times x. Now this tells me how much is taken off, right? So that tells me how much the price is going to be reduced. So I'm still starting with x, which is my total cost, and I need to take this off. So if I'm discounting, right, something's off, that's going to be subtraction. So then I would just subtract. So pay attention to how the question's being asked also, because sometimes it might say, it might be asking about like what is the actual amount that's being discounted, and in that case you would only be looking at this part, right? But it wants to know what is the new price of the item going to be, right? So you need to subtract that from the total, okay? For the second one, each night a hotel charges $70 for the first person in a room and $15 for each additional person in the room. If a room has n is greater than 0 people, which expression represents the average price per person each night for that room? So first, we need to pay attention to our linking word, right? So if I'm looking at these choices, I don't see any exponents, so I know that this is a linear equation. So that means I'm going to have a linking word somewhere that links m and x. Remember, per, each, and every are all linking words. So I'm going to link each. So that's going to link my 15 with person, right? So I know that 15 and n are going to go together. N is my variable, so that has to be person. Now, I'm being charged $70 no matter what, right? So even if there's only one person, there's still $70, okay? So I know I'm going to have 70 plus something, right? So if I have one person, though, I'm only paying $70. So that means that this, so that means like if I only have one person, I'm not going to pay 70 plus 15, right? So I'm going to subtract one person out of this 15. Because I know if I have one person, I'm only paying 70. But if I have two people, that's when I get to start being charged for the $15 extra, right? So like pretend there's 2 here, right? So 2 minus 1 would be 1. So then 15 times 1 is going to be 15. So that's when I start having to add that additional once I hit my second person. So we want to put n minus 1 so that I know that it's not the first person, but it's the second person that I get charged extra for. Alright, but now we have to pay attention to what the question's actually asking us. So it's asking, sorry, which expression represents the average? Whenever you see the word average, you're going to need to divide by the total, right? So I'm going to divide by the total number of people that I have. So no matter what, this is my equation, right? So this tells me how much I'm charging for the entire room. But now I want to know how much per person. So I'm going to divide by the number of people I have, which we know is being represented by m. Okay? So then now I need the answer that looks like this one. And that would be answer D. Okay? Next, number 8. So this is what I was talking about with recursive formulas. So the way that this works, if you don't remember, first you need to know what you're starting with. So we're starting with 5. So this is my now number. So I know that next is going to equal 2 times now plus 5. So I'm just going to make like a chart here. Okay? So 2 times now, so that would be 2 times my now was 5 plus 5. So 2 times 5, is 10. And 10 plus 5 is 15. So now I know, now my new now number is 15. So now when I do it, I'm going to plug in 15. So 2 times 15 is 30, and 30 plus 5 is 35. So my new now number is 35, right? So now let's see what it's asking. What is the fourth term? The number you start with is always number 1, okay? So then this one would be the second, this would be the third, and we need to go one more time to find the fourth. So now I'm plugging in my 35. So 2 times 35 plus 5. So 2 times 35 is 70, and 70 plus 5 is 75. So that means that 75 would be my fourth term. The answer would be D. Alright, just remember that whatever number you're starting with is going to equal 5, and you're using each number you get back into the same equation. Alright, this one says, 4 friends attempted to write the explicit expression for the nth term of the sequence. So we haven't really had much practice with this, I just want you to know whenever you see like nth term or explicit expression, you're going to need to make a chart with 2 columns, okay? The first column is going to be n, and the second column is going to be, like, you can just put total or amount, whatever. So n is just talking about the number of terms. So again, we're talking about a sequence. So this would be 1, 2, 3, 4, right? So the number of the term, this is the first term, second term, third term, fourth term. I'm just going to write in here. So 1, 2, 3, 4. Now I'm going to write what the term actually is on the other side. So term 1 was 2, right? Term 2 was 5. Term 3 was 10. And term 4 was 17. And this is how you build this table. Alright, so this, your n is just the number. So it should always go just 1, 2, 3, 4. And then it's actually, okay, so what is this term number? What is this term number? What is this one? What is this one? But now we need to pick an equation that works for this, right? So the easiest thing to do is just choose a couple of values and plug them in. So if I plug in 1, 4, I'm going to just choose Kaylee because this looks like an easy one to solve for. So if I plug in 1 here, that means I'm replacing this n with 1. So 3 times 1 is 3, and 3 minus 1 is 2. Cool, that works. So now I'm going to try it with 2. 3 times 2 is 6. 6 minus 1 is 5. That works. I'm going to try it with 3. 3 times 3 is 9. 9 minus 1 is 8. That's not 10. So it's not Kaylee because it doesn't work for all of them. So I'm going to cross her off. Now, next I'm going to try plugging in for Zoe because hers looks easy too. So 1 times 7 is 7. 7 minus 11 is a negative number, so that's not 2. So it's not Zoe. Cross her off. Next one, let's try Noah. Okay? So now I'm plugging in my numbers for Noah. So 1 squared, so 1 times 1 is 1, and 1 plus 1 is 2. That works. 2 squared, 2 times 2 is 4. 4 plus 1 is 5. That works. 3 squared, 3 times 3 is 9. 9 plus 1 is 10. That works. 4. 4 squared, so 4 times 4 is 16. 16 plus 1 is 17. So that works. So our answer is Noah because it works for all of the ones in our table. Alright, so make your table first the correct way. And then sometimes you might be asked to build the equation. So you want to find an equation that works. If you're given options, the easiest thing is to just plug in the values from your table and to see which one gives you which one works for all of your table options. Alright, let's look at number 10. Which coordinate best represents the y-intercept on the line graph below? Right here, I just want you guys to pay attention to the order that you're putting your points. So make sure you're always putting the x-coordinate first and then the y-coordinate. Okay? So the y-intercept, the x is always going to be 0, and then wherever it crosses the y-axis. So it crosses, this is 5, so it crosses at 6. Okay? Remember that up top is positive and down below is negative. Alright? Y-intercept, x is always 0. Now if you had to find the x-intercept, that means that y is going to be 0, right? So the x-intercept here would have been, so y would always be 0, and then it crossed at positive 2. That would have been the x-intercept. And just a note, y'all can write this somewhere on the side, but when you're solving like an equation for your x and your y-intercept, you guys are going to need this later, so pay attention. If you need to find the x-intercept, plug a 0, backtrack. If you want to find the y-intercept, plug 0 in for x and solve for y. Whatever you get, that's going to be your y-intercept. If you need to find an x-intercept, plug 0 in for y. Yeah, plug 0 in for y and solve for x, and that's going to be your x-intercept. Just remember for a y-intercept, x is always 0, and for x-intercept, y is always 0. Okay, hopefully, yep, that was the last one. So now you guys need to take some time. I want you to time yourself just so you're aware of how long it takes you to solve problems. You have a couple problems to solve, and then a couple explanations to fill out. Explain why you choose to eliminate answers and explain why answers are wrong or right.